Okay guys, we're back. We will take a look at the Arduino firmware for the remote control searchlight. In front of you, you will see the Arduino Editor, and this editor allows us to develop the Arduino software. And as you know, in Arduino there are two main functions, the setup function and the loop function. So in this firmware, we're going to establish an Ethernet listener, and to do that we're going to import the Ethernet library. We're also going to define the internet addresses that this listener will use and define the relay pins that we will be actuating to control the relays. If you remember, in our last session we built the test firmware to test the relays, and we used pin 24 to 32 to actuate the 5 relays that control the searchlight: on, off, up, down, left, and right. So basically these are constants defining our basic information. We're going to use a global variable here called already connected because we're going to allow only one connection from a client. And here we're going to set up a global storage and create an object, a server object. It's going to listen on port 9103. This session is not really about educating you about how network communications occur, but to give you a general overview of how you would set up a TCP listener to communicate. So in setup, the first thing we're going to do is put the pins in output mode. If you remember, in our test application we did this. We're going to put them into a high state, which turns the relays off basically. As you remember, a high logic state means relay off and a low logic state means relay on. So we initialize the Ethernet interface, providing the various address information, and we set up a serial communications to a serial console on the machine, on the host that you're running this on your laptop that you're running this Arduino editor on. This allows us to print messages so we can debug our application. Here we're going to make sure that the Ethernet interface and hardware is in place. Basically, do you have the Ethernet shield in place? And in this particular statement, we're looking for the link status. Do you have an Ethernet cable connected, and do you have connectivity? Here we're actually initializing the server, so it'll start listening and we print some information about the server. Immediately we go into the main loop, and the main loop is intended for you to loop forever. So here we wait for a connection. If you see here, we do call server available, and as I said, this is not intended to train you on the Ethernet library and the Arduino, but to give you a general overview of what we're doing. I recommend, if you're really going to program in Arduino, there's quite a bit of learning that you have to do, so take the time to go to the Arduino sites and look at the documentation. But basically here we're waiting for the connection. We get a connection client. We check to see if we already have received a connection from this client, and then we basically get the number of bytes that were sent by the client. So when the client connects, it's going to send a command. And so in our particular protocol that we've implemented, we always implement 5-byte request and a 5-byte response. We do this to simplify the protocol. Variable length messages are harder to implement at this low level, and we're able to operate with a very limited set of commands, basically relay on off for all 5 relays, basically 10 commands. So here, when we get our byte count, if we get exactly 5 bytes, we will actually read each of the bytes, as you see here, and put them in the appropriate location in a character buffer, and then terminate the character buffer with 0, which is a null. And then actually compare. We'll use a clib function to compare what we actually received. And you will see we use the C: command for command and the R command for response. So in this particular if statement, if we got a C000, we would turn relay 1 on, and we would send a response R002, which is a good response. It means command received. Here we're just printing it to the serial console so that we can debug and make sure that the commands are coming in from a debugging point of view. And of course, we duplicate this 9 more times. So relay 1 on, and here C001 means relay 1 high state, which is off. And we do that for all 5 relays. And then we loop around. We just go back around and we loop around and we wait for the next command to come in, and we look at the command and we choose which relay we should actuate, turn on or off, based on the command that it arrives. That's as simple as this program is in this first iteration. Now there are a lot of things we can do to improve its robustness, error checking, etc., and that'll be in another episode later on. Okay guys, here is the Python client software. This software will connect to the listener, the TCP listener on the Arduino, and will send commands to control the relays, basically turning the remote control light on, off, panning it left, right, up, and down. So let's take a look at a couple of constants here. So we got our command responses coming back over the wire and our commands that we send. If you remember, in the Arduino firmware, we expect to see these 5-byte commands, these C commands for command, which control each relay on and off, and we have 10 of them for all 5 relays. So we initialize the class here. We set it up, which basically creates a socket and connects to the Arduino, what's called a sock stream socket or a TCP streaming socket, and then we make a connection. And the main function is here in the main run loop. And the main run loop just loops forever in a listener waiting for key presses. And when we get a key press, either press or release, we take the appropriate response. And if you remember, when the key is pressed, say the up arrow for instance, it will command a certain relay to be turned on. And then when the relay is released, it will turn it off appropriately. Now switch 1 is for power on off, so it's a little bit different logic, right? So basically, until the key is pressed to turn the power on or the light on, we will not honor any of the other up, down, left, and right arrow keys, because why move the light if the light's not on, right? So that's what this additional logic and check is. If it's enabled, if the light is actually on, which is specified by this enable flag, we will actually toggle the light state, and then also if it's enabled or on, we will honor the actual left, right, up and down keys. So it's very straightforward. It uses a library called PyInput, and it allows you to monitor the state of the keys on your keyboard, whether it's pressed or released. And that's what's important here, because if you press a button here and you send the command for switch 2 on, which for instance is moving the light up, as long as you hold that button, the light's moving up, and as soon as you release the button, this handler is fired, the release handler, and then you turn the relay off, which stops the up motion of the remote control searchlight. So it works similarly for up, down, left, and right. So it's very simple. Obviously, as I indicated before, there are several debugging steps that are involved in this, but as a first pass client, this is a good client to start our test with and make sure we have complete remote control of the light. Okay, let's give the firmware and software a try. We will load the firmware now. In the upper left corner of your display, you'll see the green light on the Arduino. That's loading the firmware. Here you will see we're going to actuate the F1 key, then up, down, left, and right. And again, the up, down, left, and right, and the actuation of the keys. So it's working. It's great. So stay tuned. Next time, we're going to hook it all up and watch it work with the searchlight.